Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2021 NHT Physics examination. We will focus on questions related to light as a particle. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. We substitute the mass and speed into the de Broglie equation and calculate the wavelength. The number of emitted electrons and their maximum kinetic energy are dependent variables, while the different frequencies and intensities of light are independent variables. The key word is not. The maximum kinetic energy of photoelectrons depends only on the light frequencies, not light intensity. Stopping potential depended only on the light frequencies. If the frequency is below the threshold, no electrons are ejected. Calculate the energy of light in eV and compare it with the work function. If the energy of light is equal to or larger than the work function, the photoelectrons will be ejected. Here, the energy of light is less than the work function, so no photoelectrons will be ejected. 5.4 electron volts is greater than the work function, so a photoelectron will be emitted with the kinetic energy of half an electron volt. Which model of light does this photoelectric investigation support? Give 2 reasons to justify your answer. 1 mark is awarded for the model of light, particle model of light. 1 mark is awarded for 1 reason, a threshold frequency and no electrons were emitted by the 400 nanometers light. 1 mark is awarded for 1 reason, the energy of the photon is dependent on its frequency. Other findings of other photoelectric effect experiments, such as the absence of a time delay, are not supported by this particular experiment. Substitute the value of wavelength into Planck's equation and calculate the energy of 1 photon. The diffraction depends on the ratio of wavelength to wide. If this ratio is near to 1, the diffraction is significant. Here, this ratio is far away from 1, so the diffraction is not very significant. The lowest frequency of an emitted photon means the narrowest gap between energy levels. The electron dumping down from level 3 to 2 emits the lowest frequency of photons because this is the narrowest gap. The arrow must be directed down because of the emitted photon. Calculate the energy of light emitted when electrons dump down from level 3 to level 1. The units of energy are asked to joule, not eV. Convert the gap in eV between level 3 and 1 into joule, and get the answer. If the electrons are on ground level, the minimum energy pushing them to a higher level is 4.9 electron volts. 2.1 electron volts is less than this minimum energy, so nothing will happen. In light as a particle, 2 multiple-choice questions are worth 2 marks, and 3 short-answer questions are worth 18 marks. The overall score for this section is 20 marks. With a total possible score of 130 points, the percentage for this section is 15.4% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.